Hello, Mr. Hausler here. This is for Chapter 10 test prep for solving complex equations. So we have EO17, which is solving complex equations. We have a bunch of fractions in this one. So I'm going to try to solve this one called Fraction Buster by getting rid of all the fractions. So I can actually do that by multiplying everything by the LCM. So we have a 2, a 4, and a 3. I'm looking at the denominators only, so if I look for the LCM of that, the least common multiple is going to be a 12. So I'm going to take everything and multiply it by 12. And as I taught you guys in class, I'm going to multiply it by 12 over 1, so it's a fraction just like the rest of the problem is. So then I would get 12 over 2x plus 12 over 4. And then nothing happens here, I just copy it down. That 3 gets multiplied by 12, so that's a 36. Nothing happens here, just copy it down. That's a negative, so that's going to be 24 over 3x. Okay, so that's what I'm rewriting it, and it's a fraction buster because now there's no longer going to be fractions. Because this turns into being 6x, that turns into being 3, 36, and that'll be a minus 8x. From here I can start using distributive property. 6x plus 3x minus 6 equals 36x. Oh, that'd be 270 plus a 42, sorry, 210 plus a 42, 252 minus an 8x. Now I'm looking at both sides. I see x's on both sides. I'm going to try to combine those and then get them all to one side. So let's first see what I got over here. This one ends up with 9x's. This one ends up with 28x's. Okay, so I'm actually move the smaller x to the other side. So negative 9x, negative 9x gives me a negative 6 is equal to 17x plus 252. Now I'm trying to get the numbers onto the same side. Subtract 252, subtract 252. Sorry, I was thinking ahead there. That is a negative 258 equal to 17x. So I'm going to divide both sides by 17. I should get a negative number. X is a negative. Oh, I don't have my calculator. So hopefully this is the whole number. 258 divided by 17 is, and that's not. So I'm going to go 258 ABC 17 equals, and we get 15 and 3/17. So that's how you solve that guy. I'm going to leave it as a fraction rather than a decimal because it started with fraction in the beginning, so I should answer with fractions at the end. Moving over here. Complex equation. I have two different bases. This has a base of 625. This is a base of 25. I got exponents going on. I'm going to try to get them so they have the same exact base. I see 5 in both of them, so maybe they're both a base of 5. I can rewrite them that way. So I actually can with this one. So I'm rewriting this 25 as 5 to the second power. And so that is going to get raised to the x plus 2. Equal to 625. That actually is 625. 5 raised to the 5th. No, 5 raised to the 4th. It's 5 raised to the 4th. Little brain fart there. But this I'm going to rewrite him as 5 to the 4th power. Still going to be raised to the x minus 2. Okay? Now that I have them being the same exact base, that must mean that the exponents are exactly equal to each other. Now, to get this exponent, I would have to, inside, outside must be multiplied. So it's basically 5 times 2 to the x plus 2. This one is 5 times 4 to the x minus 2. Same idea, inside, outside must be multiplied. So I have that going on. That's what my exponents look like. So that means that 2 to the x plus 2 has to be equal to 4 times x minus 2 in order for these guys to be equal to each other. So I'm actually going to set I'm just going to turn the equation into that. 2x plus 2, that exponent on the left must be equal to the exponent on the right. And that's my new equation to solve. I use distributive property. 2x plus 4, 2x plus 4 equal to 4x minus 8. Move the variable, the smaller variable, to the other side. 4 is equal to 2x minus 8. Move the numbers to the other side. 12 is equal to 2 times something. That missing something is a 6. So there we go for EO 17.